Okay, imagine that we're in a large lecture hall, and there are 200 people in the lecture hall, and 100 of them are male, and 100 of them are female. Moreover, we know that each person drove to the lecture hall separately, and they each have their own car. When we look out in the parking lot, we see that there are 40 red cars, 70 black cars, and 90 white cars. What I'm going to ask right now is, what will we expect in the cells of this table if there is no relationship between gender and color of car that someone drives? Well, since we have a 50-50 split between males and females, if there's no relationship, we would expect an even split 20-20, 35-35, and 45-45 in these cells. Now, we're going to call this something special as we go on, and we'll see this frequently. We're going to call this the null hypothesis. The null hypothesis, what we're going to do is have competing hypotheses. The null hypothesis is nothing's happening. There's no relationship. When we get to talking about means, there is no difference between the means of two groups or three groups or whatever, and so on. So it's the hypothesis of no relationship, or the null hypothesis, and we'll symbolize that as HO. Okay. It's important to know this is not the data. These are not actual data points. This is what we would expect if there's no relationship. So now let's see how we can use that. We're going to go out and collect some data, and let's say that our data looked like this. That we had $21. I'll go ahead and write the numbers out here so I can keep it straight. $21 and $19, and here we had, let's say, $36 and $34, and so that'll leave us with $43 and $47. So this is the data that we might collect. In this case, I'm just watching people go out to their cars and looking at the color of the car and whether or not a male or a female gets into the car. And so this is what I observed. 21 males got into red cars, 19 females got into red cars, and so on. So here's the thing. This is about the same as what we'd expect if there's no relationship. Therefore, we will conclude that there isn't, or we will conclude that we can't say that there isn't a relationship, that the difference that we observe between 20 and 20 and 21-19 could just be chance. So we'll say that the null hypothesis could be true. Let's contrast that with a little bit different example here. And this time, we still have the 40, 70, 90. None of the cars have changed colors, and everybody that was male has stayed that way, and so on. Couldn't help it. Red, black, and white here. But this time, let's say that when we looked at the red cars, that we had 10 and 30 for our split here. 30 females in red cars and 10 males. And for the black cars, let's say that we had 50 and 20. And then that would leave us with third, let's see, 50 and 40. Well, note, especially in these first two rows here, some in the other one, but especially there, this differs from what we would expect if there's no relationship. Therefore, if we get this data here, we'll call this data set 2. If we have data set 2, we're so far apart from what we would expect if there was no relationship that we're going to conclude that the null hypothesis of no relationship is not true, and that there must be a relationship, or that we're confident that there's a relationship, not must, that we're confident that there's a relationship between gender and car color.